Hi, I'm Dr. Zia Tahir. This video tutorial is solution to problem for by 16 of Engineering Mechanics Static 9th edition by Meriam, Craig and Jan Bolton. Statement of the problem is that rectangular frame is composed of 4 perimeter 2 force member and 2 cable AC and BD which are incapable of supporting compression. Determine the forces in all members due to load L in position A and then in position B. So there are two parts of this question. The part 1, the load is acting at B, and in part B, the load is acting at point C. So need to find member forces in all members. So member forces are required in all members. So this problem I'm going to solve using method of joints. So let steps to find member forces using method of joints are listed here. The first need to select a joint with at least one known force and two or less than unknown. And if no joint satisfy the condition, need to determine force reaction first. So then uh, once any joint can satisfy the condition, then need to isolate the joint and draw a free body diagram, assuming all member forces in tension. Arrow away from the joint and then need to apply conditions of equilibrium sigma fx and sigma fy equal to 0 by resolving inclined members into components. And then after finding answer, the interpretation of sign is a positive value indicate tension and negative value indicate compression. So I'm going to solve this question using method of joints now. So the two parts of the question, part A, the load is being acting at B, and then in part B, the load is acting at C. And then two cables AC and BD, they are incapable of supporting compression. So first I'm going to do part A. So in part A, when the load is being applied at point B, so then this load is going to act vertically downward. So then this BD will be in compression to support that load. And then in the statement, AC and BD are not capable for compression. But when the load is being applied there, so AC will be in tension. So then, because BD is not capable of supporting any compression, so then I'm going to assume that BD is in compression. So member force in BD is equal to 0. So when the member force in BD is equal to 0, so then I can simplify truss as removing BD from there. So applying steps on a modified version of the truss. So I'm going to select a joint with one known force. So now B is a joint which has one known load and then two member forces. So I'm going to start from joint B and then need to isolate the joint and need to draw a free body diagram, assuming that member force is in tension. The free body diagram of joint B is shown here. Known load L is going to act and AB and BC are in tension. So then I can simply apply sigma fx and sigma fy equal to 0 to solve this joint. So applying sigma fx equal to 0, so there is only one force in horizontal direction which is equal to 0. So AB is equal to 0 and then applying sigma fy equal to 0. BC is acting vertically downward, so that's negative, and load is also acting vertically downward, so L is negative. So then I can simply write minus BC minus L equal to 0. So BC is equal to minus L. So then once member forces are computed, then interpretation of the sign of unknown member force, a positive value indicate tension and a negative value indicate compression. because BC is negative, so BC is will be in compression, whereas AB is 0. So once all three steps done, then step 4 is repeat step 1 to step 3 for adjacent joints that now have two or less than two unknowns. So then from B, I can go to joint A, and joint A that has three member forces and two reactions there. So I cannot go at joint A. So the other adjacent is joint C. So at joint C, AC is in tension and CD is unknown. So simply at joint C, there are two member forces. So I can now isolate joint C to find member forces. So that's free body diagram of joint C now. So at joint C, now BC is known in compression L, and then CD and AC. So AC is an inclined member. So the component of AC can be computed using triangle ACD. In that triangle, its horizontal side is 3D and the vertical side is 4D. So that's now joint with sides of the triangle and component of inclined member AC. AC towards left or in negative x-axis, ACY is upwards. So I can, using the triangle, I can find the component of AC as AC times horizontal side of the triangle divided by the diagonal. So diagonal is 5D, or hypotenuse is that 5D. Then Fy is equal to AC times vertical side of the triangle over diagonal. So now in horizontal direction, there are two unknown, and in vertical there is one. So I'm going to start with sigma Fy equal to 0. In sigma Fy, AC is positive, then L is negative. So AC plus AC minus L equal to 0. So now ACY is AC times Y component is calculated as vertical distance over Z is equal to L. So AC comes as plus 5 over 4L. So once that AC is calculated, then I can apply sigma fx equal to 0. So both are towards the left in negative z x direction. So then both are taken as negative. Now AC is already calculated as 5 over 4L, and x component will be uh, x side over horizontal side over the diagonal, so which is 3D over 5D. So CD comes as minus ACX, so AC times 3D over 5D. So then AC is 5 over 4L. So after substituting, CD comes as minus 3 over 4L. So now the values are calculated. So a positive value of that answer indicate tension and a negative value indicate compression. So AC is positive, so that is 5 or 4L in tension, and CD is negative, so that is 3 by 4L in compression. So that joint C and the member forces at joint C are calculated now. So the member forces of joint C are now calculated. So then adjacent joint to C is either D or A. So at D, there is one support reaction and there is one unknown member force. So joint D that has two unknowns, whereas joint A is a pin support. So that pin support has two unknown reactions. So joint A has now 1, 2, and then so that AB is 0. So AB is 0. So it has three unknowns. A joint A. So one unknown member force and two unknown reactions. So I cannot go to joint A. Then I have to use joint D. So now that is a free body diagram of joint D. At joint D, there is one member force AD. I have assumed that in tension. And then at joint D, there is one reaction. And that reaction is perpendicular to this surface. So I have assumed that reaction dx towards left. And then I can apply conditions of static equilibrium to find AD and DX. So at joint D, only AD is required because reactions are not required in the question. So I can apply sigma Fy equal to 0. So sigma Fy AD is equal to 0. So AD is equal to 0. So then I can show all the member forces on the structure on the truss. So now from here it is being verified that AC is in tension. Okay, so when the load is applied at B, so then AC is in tension, and that is the complete solution of part A when the load is acting at point at joint B. Now part B of this question, so when load L is going to act at joint C instead of A, so that is a condition. So now the load is going to act at joint C. So when the load is going to act at joint C, so then when load is acting, so there is obvious thing that AC is in tension. When AC is in tension, so then BD that will be in compression. So when the load is acting at joint C, so then BD is in compression. So assuming BD in compression, so BD is not going to take any compression, so BD is equal to 0, and now that is a modified truss. So now I can start analyzing the new modified truss. So now the only load acting is at point C, and it has three unknowns. So only one known force is there and three unknown force, and any other joint doesn't have any known. So to solve this truss, the first step condition is not being satisfied. So need to determine support reactions at A and D. So these are steps to find reactions in truss. So need to draw a free body diagram of entire truss, ignoring internal member AC and replacing supports with reaction. So at A there are two reactions, and at D there is one reaction. So assume suitable direction of all reaction. So you can choose any direction of reaction, but when you will get the results, a positive value of reaction confirm that assumed direction, and a negative value means actual direction is opposite. So need to reverse the arrow and need to use that magnitude only, mean that just ignore the negative sign and use its value. So I'm going to draw a free body diagram of the whole truss to find reaction forces. So that's the free body diagram of the truss. So supports are replaced with reactions. So then I'm going to find these reactions, and the best one is need to apply equilibrium to the whole truss. So first need to apply sigma m equal to 0 and need to choose a moment point that has most unknowns. So the suitable choose moment point, or the point about which I have to take moment, is A. So when I'm going to take moment about point A, so it is going to eliminate these two unknowns. So I can easily find that D. So now I can take moment about point A. So that is the line of action of L. So that is going to act along BC, and it is going to produce moment in AB in clockwise direction. And DX is going to act along CD, and its perpendicular distance from the line of action to point A is 4D, and it is going to produce moment in clockwise direction. So both moments are taken as negative clockwise. So L times 3D and the other one is dx into 4D. So minus L times 3D minus dx times 4D. So it can be rearranged to get dx as minus 3 over 4L. So now dx is calculated. So next I can go for sigma fx equal to 0. So for sigma fx equal to 0, both ax and dx are assumed towards right. So then both are negative. So minus AD minus DX is equal to 0. So I can calculate AX is equal to minus DX. And minus dx is already calculated, so ax comes at plus 3 by 4l. Then I'll go for sigma fy equal to 0. For sigma fy, ay is assumed as upward and load is acting downward, so then it's plus ay minus l equal to 0. So ay is plus l. So now uh, here a positive value confirms the assumed direction. So whatever is the suitable direction was assumed, so that confirms the assumed direction. So and then a negative value mean that need to reverse the assumed direction. So now ay is positive, so it means that its direction is upward. Ax is positive, so it means that its assumed direction towards the left is again correct. And dx is negative, it means that its assumed direction need to be reversed. So then dx is going to act towards right. So that is now the reactions are calculated. So now after finding reactions, you need to select a joint with one known force and two or less than unknown. So joint D. That joint D, now dx is known, and then it has two member forces AD and CD. So those are two unknown. So I'm going to start with joint D. So need to isolate the joint, then need to draw a free body diagram of it, and then uh, unknown member forces need to assume in tension, and then need to apply conditions of equilibrium. So joint D is isolated, and then that's a free body diagram of the joint D. So AD and CD, they are assumed in tension, whereas DX is acting towards right, which is 3 over 4L. So at joint D, applying sigma Fy equal to 0, so there is only one force in vertical direction, so AD is equal to 0, and then applying sigma Fx equal to 0, so CD is positive, and 4 by 3L, the reaction is also towards right, so that is also positive. So plus CD plus 3 over 4L is equal to 0, so CD is minus 4 minus 3 over 4L. So AD is 0 and CD is negative. So then a negative value indicate compression. So CD is in compression and AD is simply 0. So CD, that is shown in compression, which is 3 quarter L, and BC is 0. So now I need to go to the adjacent joint. So joint C now. Joint C that has two unknowns, and other adjacent joint A that has three unknown member forces. So I'll go at joint C. So joint C is isolated and its free body diagram is drawn. So it has one known L, the other one is 3 over 4L in compression. So AC and BC, so they are both assumed in tension. And to find the component of AC, I'm going to use the triangle ACD with horizontal side as 3D, vertical side as 4D, and its diagonal is 5D. So now AC is resolved into its component ACY and ACX. So there is one unknown in horizontal direction and two unknown in vertical direction. So first I'll apply sigma fx equal to 0. So applying sigma fx equal to 0, so say AC is negative and CD is positive. So now ACX plus 3 over 4L is equal to 0. And ACX is AC times by the horizontal side of the triangle divided by the diagonal. So AC times 3D over 5D, and that is equal to 3L. So AC computed as plus 5 over 4L. So once AC is calculated, so then I'm going to find sigma Fy equal to 0. So for sigma Fy, it is ACY and BCY, both acting vertically upward. So both are positive, and then a load is acting vertically downward. So ACY plus BC minus L equal to 0. So then I need to find BC, so which is equal to L minus ACY. So component of AC in Y direction will be 4D over 5D. So then AC is already calculated at 5 or 4L. So by substituting the value there, so BC comes at 0. Now BC is 0 and AC is plus 5 or 4L. So it means that AC is in tension. So once again, I need to go to the adjacent joint. So after C, the adjacent joint is A or B. Now BC is equal to 0. So and then at joint B, there is only one unknown member force AB, whereas at A is the same. So I can use either of the joint, and I'm going to use that joint B here because it has two forces members only. So free body diagram of joint B is drawn. So AB is assumed in tension and BC is 0. So ideally it is going to give AB equal to 0. So at joint B, only unknown is in horizontal direction. So applying sigma fx equal to 0. So AB is equal to 0. So then by putting that AB equal to 0, so now this also confirms that AC is in tension. So AC is in tension. So that is a complete solution to this problem. Thank you very much for watching.